Here this question says, for what values of P the following series is convergent? So you want the series to be convergent. I notice that there is -1 the power n plus 2 in this series. That means that this series is an alternating series. Okay, that's the first observation. Other than -1, what is left in the series is Bn. I'm going to name it. Bn is 1 by n plus p. So that's the remaining part of the general term. Now, this is an alternating series. That means I can use to AST to test if this series is convergent or not. For AST, we have two conditions. The first one is that limit n approaches to infinity of Bn should be 0. Bn is this. So we need to check limit n approaches to infinity 1 by n plus p. Now, if n is approaching to infinity, n plus p should be pretty large number. N plus p should approach to infinity. So 1 by infinity is basically 0. So this first part is easily tested. That limit of Bn as n approaches to infinity is 0. Second condition is to check if Bn plus 1 is less than Bn for all n. Okay. Now, basically we need to prove that Bn is decreasing. Okay. So let's see what is Bn plus 1. That is 1 by n plus 1 plus p. And Bn is 1 by n plus p. Clearly, n plus 1 by p is more than, what do we know? We know that n plus 1 plus p is more than n plus p for all n. So when you reciprocate it, clearly this would be less than 1 by n plus p, because when you reciprocate a inequality, it changes the sign. So this is clearly less than. So second part condition is also verified. So using AST, the alternating series test, we can claim that this series is always converging. Always converge, provided the term Bn is valid. Now, only possibility when this will not be valid, when this is, we want this to be valid, right? Only possibility when this is not valid is when n plus p will be equal to 0. When can n plus p be 0? If at any point p becomes -n. What is n? N is all the whole numbers from 1, 2, 3 and so on. So p should not be equal to negative n's for all n. What does that mean? That should be p cannot be -1, p cannot be -2, p cannot be -3. So basically we say p can be any real number but not integer. Negative integer, not negative integer. P cannot be a negative integer because we cannot have P cannot be -1, -2, -3, because that will make some of the terms to be invalid. We want Bn, the term itself, to be valid. The term will be valid if the denominator is not 0. So that is the only condition. We can have any P value except negative integers.